LeetCode 141, linked list cycle. Given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. And here's an example where we're given nodes 3, that goes to 2, that goes to 0, that goes to 4, that then goes back to 2. We can clearly see there's a cycle. The approach that we're going to be taking is called Floyd's cycle detection algorithm, or tortoise and hare algorithm. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal solution to this problem. Now let's walk through an example. 3, 2, 0 and 4. Step 1. Declare two pointers, fast and slow, both starting at the head. We can see F for fast and S for slow here, pointing at 3. Step 2. Loop over each node while fast and fast.next is not null, applying the following logic. Fast is equal to fast.next.next, so let's update the fast pointer. Check if fast is equal to slow, which we can clearly see it is not. So then update slow to slow.next. Then back to the top and set fast equal to fast.next.next, which we can see is 2. Check if fast is equal to slow. It is equal to slow, so let's return true. And note step 3, if we break out of the loop, there is no cycle and we need to return false, so return false. Thank you very much for watching, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Now let's look at LeetCode Problem 141, linked list cycle in JavaScript. Given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. Example 1. We're given a linked list with nodes 3 that goes to 2, that goes to 0, that goes to -4, that then goes back to 2. So we can clearly see that there is a cycle. So the output of this is going to be true. Example 2. We've got nodes 1, nodes 2, and then nodes 2 goes back to 1. So we can clearly see there is a cycle in this example 2. So the output's going to be true. Example 3. We're given a single node, which the output's going to be false because you can't have a cycle when you've only got one node. There's no link. So in terms of edge cases, I can think of a few. One edge case is going to be where you're given a empty list. That is, head is equal to null. In that scenario, the result would be false because obviously there is no cycle if there is no nodes or no links. Another example, which was shown in example 3 here, is where you're given a single node. So when you're given a single node, the result is always going to be false. You can never have a link between nodes or a cycle. You can never have a cycle in the links if there are no links. Another scenario which has not been given in these examples would be where there is no cycle. So imagine that this -4 node didn't point at 2, well then this would return false because there would be no cycle. So there's some edge cases that I would bring up when sort of interviewing, and let's get into it. So the first thing we're going to do is we're going to declare a slow pointer and a fast pointer. So let slow equal head and let fast equal head. We then want to loop over using the fast, so we'll say while fast, and fast dot next. Then we'll say fast equals fast.next. We're saying next twice because this is our fast pointer. Then we'll check if the fast node equals the slow node. If that's correct, then it means that we need to return true because we do have a cycle. If not, then we want to update slow by 1 equals slow.next. And then if fast and fast.next becomes null, it means that we've got to the end of the linked list without there being a cycle. So in that scenario, we want to return false. And the reason that this works is because if there is a cycle, the fast moving pointer will eventually land back onto where the slow pointer is. And that's how this works. And you can see it in my whiteboard walkthrough previous to this. So let's run that and see if it works. It does. Now let's submit it, see if it passes their edge cases and tests. Which it does. Great. It says that it beats 53.09 in terms of runtime, and it says it beats 14.18% in terms of memory. I can tell you that the runtime complexity is O of n, and the space complexity is O of 1 constant, and this is the optimal solution to this problem. I hope that this clarifies the problem and solution for you. Please, if you could click like if you like the video, that'd be great. And a massive thing would help me out would be if you could click subscribe, because it will really help with the YouTube algorithm. If there's any feedback that you've got for me, please leave it in the comments below. And thank you very much for watching, and good luck with your coding.